All right, everyone. This is just a quick video to demonstrate Antonio Subirats' obsession with the scalene triangle. I would normally leave a comment on Antonio's video, but he has me blocked there, presumably because I've commented a few too many times with corrections to mistakes he's made. So instead, I'm just going to make this quick video. It shouldn't be more than a few minutes. I have links to a video from Red's Rhetoric and a video from Astronomy Live. And then I have links to two of Antonio's videos, his first response to the ISS calculation and his second response to the ISS calculation. What I'd like to do now is play, and I don't know if you're going to be able to hear this. I'll narrate as he goes through. I just want to play a few seconds of Antonio's latest video.
This is slightly exaggerated for ease of interpretation. This was the location of Astronomy Live. This was the location of Red's Rhetoric. Between Astronomy Live and this center line was 668 meters.
Okay, so Antonio is saying that one of the observers, either Red's or Astronomy, was 668 meters from the center line of where the ISS was going over the Earth. Okay, 668 meters.
Between Red Rhetoric and this center line, this transit line, was 451.
Okay, so Red was 451 meters away, and Astronomy was 668 meters away. Now, if we do 451 plus 668, we get 1,119 meters, which is 1.119 kilometers. Now, later in the video,
668 versus 461.
Now he changes it to 461.
Was 1,129.
Okay, so he gets 1,129 because even though he's written 451 here, and you can see 451 written here, and if I go full screen, I think it's still 451. Yeah, 451. He adds 10 in somewhere. I don't know where, and I don't know why. So he gets 1,129. We're going to use 1,119 as our value. So let's go down here. Let's put in 1.119 kilometers. Okay. So I have here a simple GeoGebra demonstration. What I'm going to do is scroll out. Okay. So I have an angle up here. I have D. D represents the ISS. And then I have a line drawn on the baseline here on the x-axis. We have 2 points, A and B. These will be Astronomy Live and Red's Rhetoric. We know the distance between these 2 points is 1.119. So that's 1.119 kilometers or 1,119 meters. Now, in their video, they posited that they were essentially exactly in the middle, equidistant from the center line of the ISS. That's what they used in their video to make an isosceles triangle that they divided in half to determine the distance from C to D, and D is the ISS. And what Antonio Subirats is saying is that they actually had a scalene triangle, not an isosceles triangle to begin with. So there should be 668 and 451. So let's put this at 6.68. 6.68. Okay, so we have 668 and 451. Now, the angle that they measured was 0.1212 degrees. Okay, this is the value now of the same triangle from A to D all the way up there and down to B. That angle there is 0.1212 degrees. Watch its value as I move C. It goes as low down as 0.1211999 and 0.1211999 again. And in between there, we get 0.1212 with varying digits after the decimal place. What this is indicating is that because this angle is so small, this point here can really be anywhere between points A and B, because the distance from A to D and the distance from B to D and the distance here from C to D, the altitude of the triangle, is so many more times the distance from A to B. So what that means is they could have been spaced like this and still gotten practically identical values. Because again, they probably would have rounded this up to 0.1212 degrees. So what this shows is that, sure, it was a scaling triangle, but Antonio hasn't actually changed the math at all. Perhaps what he doesn't know is that when you have a triangle and you have a base and an altitude up to the third point, this altitude is going to be the same no matter where you slide the base. Okay, so if I slid this base all the way over here, so we had our 1.119 meter base, a kilometer base here, and the ISS all the way up here, the altitude of the triangle, the perpendicular length here, would still be the same. The line from C to D is the same length, no matter where along the line AB I put point C. And we know this because I can even tell you what the length of the line is. Let me show you that length. Come on. Let me show you the length of the line from point C to point D. Okay. It's 528.9926. There it is, right down there. So if I zoom in, see how that distance doesn't change, 528.99266? It's because the altitude of this triangle doesn't change no matter where the baseline is, so long as the baseline moves along the same line, the altitude of this triangle will never change. So Antonio, thank you for pointing out that their triangle is scaling, but you haven't modified their math really in any way. You've only cemented the fact that the distance from them to the ISS was about 529 kilometers, and they got a value, I think, of 527 kilometers or 524 kilometers. So really all you've done is help us refine just a little bit the distance to the ISS. So thank you for confirming that the ISS is indeed a couple hundred kilometers above the surface of the Earth.